Hi everyone, welcome to this new tutorial. Today I will teach you how to make a Sonic themed infinite runner game in JavaScript using the Play library. So what are the prerequisites for this? You need to know JavaScript, otherwise there isn't much else. So the Play library is a very easy to use library for making games, and I'm going to teach you how to use it in this tutorial as well. So here is the game in action. So it's a simple one button game where you need to jump over enemies, or you can bump into them like this. And the goal is to have the highest score. As you play, the game is going to get faster, and then you get you get hit. And then this is how you lose, and you have a ranking at the end. So depending on your best score, you have here rank D. Well, now I got rank 50 F, sorry. So the goal is really to collect as many coins, but also try to have this bump. So when you jump, Sonic is invincible. So you can use this to your advantage to try to bump on enemies, and you multiply your score by doing this. So let's play it a bit, and let's try to go a bit farther. So here I'm playing with the mouse, so you're going to see how we're going to use Kaplay's new input system that allows us to configure multiple inputs really easily. So here we go. As things go faster, it's going to become more and more difficult. So that's the game. Maybe one last try before we jump into it, and I will teach you how to make it. So here we go. Score 42. You can see that we have a nice parallax effect in the background. And I'm going to teach you how to achieve that as well. And yep, and when you jump, the background goes down a bit, and when you land, it goes up, and it gives this nice effect that you can see in old Sonic games. So here we go. Here we go. I just want to reach a point where it gets really, really fast. So that's a nice twist on the infinite runner genre, where, for example, the Chrome Dino game, if you're familiar with it, it's basically the same principles, but I added some Sonic mechanics, like the fact that Sonic, when you jump on an enemy, they die basically, and the fact that Sonic, when he jumps, he curls into a spin and then becomes a slightly invincible for a while. So here we go. As things go faster, it becomes harder to succeed, but I really like that the sense of speed that you have in this game. It's really like Sonic, and that's how the idea came to do it. Because in those infinite runner games, you usually get faster and faster and faster, etc. So that's on the game basically. So by the way, just before we jump in, if you want to know how to make infinite parallax scrolling in JavaScript using the Kepler library, I've written a post on it. This is my Substack. It's where I write written content, and usually my Substack is complementary to my YouTube channel, where my YouTube channel has bigger projects, like now, but my Substack really contains how to do stuff, very specific stuff, so that is easier to reference. So I suggest that you take a look and maybe subscribe as well to receive those in your email inbox. So I have many posts now, so the link will be in the description and in the comment section. All right, let's get started. So I'm going to use VS Code as my code editor. So VS Code is really like the most famous code editor, I guess. So feel free to use it or not. In this tutorial, we're going to use npm as well, so you won't need to add any like extensions or anything to run a server. So you could use any editor with this tutorial. So let's create our project. So I have a VS Code opened already on an empty folder called sonic-runner-game. Call it however you'd like. So let's go into the terminal here. By the way, if you don't know how to achieve this in VS Code, you go, I think, view and then terminal, and then it will appear. So I'm going to write the command npm create vite at latest. So sorry if this sometimes my terminal bugs like that. I'm just going to remove that and try it again. Let's see. All right. I'm going to also increase the font size of everything so that you can see. So npm create vite at latest. So Vite is the bundler we're going to use. So by the way, I assume that you know what Node.js is. So Node.js is a way to run JavaScript outside of the browser. So npm has become the de facto way, like you install. It's a package manager to install packages. Here, Vite is a bundler, which will allow us to bundle our code into code that is that can run on the web. So Node.js, the JavaScript code that you write in Node.js is not exactly the same as the one that you write in the browser, and there can be some differences. So by using a bundler like that, it can bundle that code and make sure that it runs on the web, but also it can make sure that the code is also minified into a single file, etc. So, yeah. Now, let's hit enter. So npm create vite at latest dot will create the scaffold, the vite project inside of the current working folder. So I'm going to choose vanilla for our framework. I'm just going to use vanilla.js. So here we go. I'm going to select JavaScript for this project, and then we can already start by removing some of the boilerplate here. So the important part here is that you have a package.json. I'm going to remove style.css, counter.js, and even main.js. We don't need those files. I'm going to create a file called source, which is going to contain all of our code. In index.html, I'm going to make sure to point the source for the script tag to source here. And inside of our source folder, I'm going to create a main.js file. Now, here for the assets, we're going to put our assets in the public folder. So what I'm going to do is I'm going to drag and drop them. So here we go. So the fonts, the graphics, etc., the sounds as well. So you're going to find this inside of the description. There should be a link that will point you towards the various assets you need for this project. So feel free to look down in the description. Also in the description, you should find a live demo of the games if you want to try it out before maybe following this tutorial, in case you're not convinced. So here we go. And now we can open back up our terminal like this by just dragging upward like that, or using the same view and then terminal. And then here, what I'm going to do is I'm going to do npm install and then Caplay, which is the library we're going to use. So Caplay is very easy to use to make games, and that's why I like it a lot. So now that Caplay is installed, you should be ready to go. And now here in the main.js file, just write import Caplay from Caplay. By the way, we're not gonna, okay, let's just do it for now. Let's do it, and then we're gonna change this later on. So we have import Caplay from Caplay, and then to initialize the Caplay canvas, you do Caplay, like I call the Caplay function. And now here in the terminal, you should write npm run dev, and then using this link, you can open up in a browser. Let's say I'm just going to open up here, and you have a canvas that takes the whole space. Now for this project, we want to have actually a fixed aspect ratio. So I'm going to specify inside of the Caplay. So this constructor, this function, is what initializes the canvas in which the game is going to be displayed. So if you look at your index.html file, there is no canvas element here. There's actually the default div. I'm going to remove that, which is from Vite. By the way, vite.svg here, I'm just going to keep it just to keep, so we don't get the favicon error or something like that. It doesn't matter really. If you're going to host your game on a website like itch.io, it doesn't matter. So here, main.js, this is how you initialize your game in Caplay. Then you can optionally pass an object as a param and specify a bunch of options. So the options you can pass is the width. So the width of our game is going to be 1920 by height of 1080. So this is a full HD resolution. If I do this like that and then look at the result, yeah, so you can see that I have scroll bars, and that's not good because we want our game to adapt to our window size, but while keeping the aspect ratio. So if I go here and type in letterbox, set this to true, the letterbox option is going to make sure that it's going to scale the canvas in a way that is going to keep the aspect ratio. So here we go here. By the way, one thing I forgot to add is that for this tutorial, we wrote npm install kplay, which installed this version. If you look at this tutorial, if you watch this tutorial far into the future, it might not actually point to that. So I'm just going to teach you how to install a specific version. So I'm going to Control C here to terminate our web server. And here in the terminal, I'm going to do npm install and then kplay, and then you do at and then the version. So here it's 3001.0.0 alpha, point 0 dash alpha dot 21. So if you watch this tutorial in the future, you run this command and not just a general npm install kplay. Now, there is an issue with this version of kplay. At the moment, the mobile version. So when you try to open a kplay game in mobile, Android Chrome, so in the Chrome browser on an Android device, it won't work. So the game will be pitch black, but you're gonna hear the sounds. So this is an issue, an ongoing issue. I have reported the bug, and yeah, so they're probably going to fix it, maybe, hopefully. So in case you're watching this in the future, maybe bump this up by 1 or 2 versions, but I would suggest that you follow the tutorial using the exact same version, and then after you have done the tutorial, when you're playing around with the result and maybe trying to modify it, then feel free to bump the version and then upgrade to the what is latest in the future, I guess, for kplay. So once you do npm install kplay, the specific version like that, it's going to install it. Now, if you already have installed kplay, the exact version, nothing is going to happen. But if you had another version, this would change immediately. So you would see it change in the package.json file. All right, so now I have letterbox 2. Let's rerun our web server. So npm run dev, because we have stopped it earlier on. So now if I go back here and refresh, you can see that our canvas really keeps its aspect ratio of 1920 by 1080, but not black bars, but here white bars are put so that the aspect ratio remains the same. And yeah, so that's an important configuration. Now for this project, I want my black bars to be black, and you can specify a background color by using the background property and then specifying the colors, so RGB values in an array. So 000 corresponds to black. So those values can vary for each element here by 0 to 255. So now that you have done this, and if you look at the result, you can see that everything is black. So there's nothing to see. All right, so now usually I don't do this here. I usually create a second file in the source. I call it kplay ctx for context. And the reason I'm going to do that is because I want to use kplay in a non-global way. So by default, if you just import kplay from kplay, there are many functions that are in the global namespace. That means that you can call them directly using their name, but sometimes it can occur that certain functions in kplay can conflict with other functions from other packages or libraries you want to use. So for example, I don't have a specific example in mind, but it could happen. So a way to mitigate that and make our code, let's say, cleaner and easier to understand is to create a context. So a specific constant from which every method from kplay will be called. So here in main.js, instead of having this here, I'm going to take it and paste it in the ctx kplay ctx.js file. I'm going to remove everything here and hit save. Now here, I'm going to create a constant and I'm going to call it k, which is going to contain the context of kplay. So now when we're going to want to call kplay functions, we can just do k dot and then the name of the function, the kplay function we want to use. However, this by itself doesn't do anything. you need to specify that you want in the options object that you want CapLay to not be imported globally. So you need to set it to false. So after you have done something like that, we should be ready to go with our project. But of course, we need to export that. So if you do export, you can export it like that, but you're going to have to use brackets. So if I do import k from CapLay CTX, and you can use the k like that. But because the only thing we're gonna import outside of this file, so the only thing we're going to import from this file is going to be the k. I prefer to do export default constant, but for some reason you cannot do that here. You cannot use the default in a single line. You need to first declare the constant and then type in export default k. So now what this does is that when I'm going to go here, I can just do import k from oops, CapLay CTX, CapLay context. Oh, that's why I got a typo. So now let's go. So one thing also we need to do if we want our game to be supported on mobile, as I said, there's a bug currently in Android Chrome that makes the CapLay games not work, but you can still use Firefox or other mobile browsers. So you want really to have this property activated. So touch to mouse being true. That means it's going to translate any click input to any touched input to clicks, as if it were clicks, so that you can write your code as if your game would be played on a desktop with the mouse, and it would work the exact same way on a mobile phone as well. So that's basically all of our options. There is now another one that if you are not new to the channel, there is a new system, a new input system, a way to have input. So that's very handy. And the way you configure that input system is by doing it here. So you specify a buttons object, and then here you can create your buttons, which will correspond to many different inputs. So it allows us to not have to repeat ourselves. So in the past, when you wanted to use CapLay, you would have to write your logic for each button. So for example, if I want the same input to happen for both a mouse click, a touch, and a button press in a keyboard key press, and a button press on a gamepad, I would have to call 4 different functions with the same and pass in the same handler. But now with this new input system, you don't have to do that. You just create your key. Let's say we're going to create the jump key. So this is an arbitrary name. I decide to name it this way. You could have decided on another name. And then here you can specify the keyboard property and then pass in an array of keys. So you can have multiple keys that works for the same button you created here. So here I want the space button. So for example, if you want your game to be playable by someone on their keyboard by both being able to either use WASD or the arrow keys, you can do that by specifying the keys here in this array. So I would put, for example, the A here and the arrow, I would say up, etc. So you would do this here at once, and that will save you a lot of time later on. But here in this specific game, in the Sonic game we're building, we don't really need that. What we need is actually just to have the space key on the keyboard, and we also want for the mouse to have the left click. I could have also added the gamepad, but you know what? In this tutorial, it's not really worth it to implement gamepad controls for a one-button game. All right. So nobody's gonna pull out their controllers just to play a one-button game, you know. So here we go. So now we have this. I think we have everything needed. There's one property left I want to add, is the debug property. This by default allows you to access the debug mode. I think there's also a debug key. So one thing is, in CapLay, there's a debug mode that you access by pressing F1. However, if you use another browser, let's say the Edge browser, pressing F1 will not actually open up the debug mode well, it actually is going to open it up, but it's not going to, it's also going to open another page, and this can get really, really annoying. So here I'm going to specify a debug key, and let's say that our debug key is going to be D. You could decide on any key you want, but yeah, D would instead of F1, etc. So choose a key that you're not going to use in your game, and you're going to just use for debug purposes. And another property we need to add is the debug. So here, by default, when you start a Kplay project, the debug mode is always on. That means that if you publish your project and someone knows the standard debug key, F1, they can click F1 and they will see the debug mode. So what I recommend is that when you finish developing your game, you specify the debug key and set it back to false. So by default, it's true. So here I'm going to set it to true, and hopefully I will not forget, but I always end up forgetting, except this time for this Sonic game, I actually remembered to deactivate the debug mode. So now let's look at the result. So here, by pressing D, you can see the debug mode with an FPS counter of 60. Here in debug mode is when you're going to see the, how do I say it? You're going to see hitboxes, etc. For now, everything is pitch black, so there isn't much to see, but you're going to see how handy it's going to become. So yeah, I recommend pick a key here and don't forget it. All right, so now that we have our context ready, we can go back to main.js, and in main.js, we're going to start importing our assets. So for our assets, let's take a look at what we have here. We have a font, the Mania TTF font. So by the way, a lot of the, I would say all of them are from the game Sonic Mania. So I thought the sprite work was really nice in this game. So I thought I would use it. So here we have the chemical background, which is going to be the, it comes from Sonic 2, and it's the background we're going to use in the background of our game. And I'm going to use the technique that I've explained in the Substack post on how to have a parallax scroll with that. Here the character, the Motobug, is going to be the enemy. The platform here, it's going to be the repeating platform we have. As you go faster, this repeats itself, so it's infinite scrolling as well. We have rings animation here, a single animation, and we have Sonic here with the running animation and the jumping animation. So this project in terms of assets very easy, and that's really great if you're a beginner. As for the sounds, we have a bunch of sounds here. Here the city.mp3 is the sound of a city, like noisy, just to have some ambience. The destroy, anyway, you're gonna hear them. So you have the when you collect a ring, when you jump, when you get hurt, etc. So those sounds also come from Sonic Mania, except the city one, I just picked it up from somewhere else. All right, so here in our main.js, let's import our assets. So the way you import assets is you use the load sprite if it's a visual asset, so if it's an image. You specify as the first param the key you want to use, so the name you want to give to that asset. I'm going to call it chemical background, which comes from the chemical plant zone in the game Sonic 1. I think, yeah, it's the second zone of Sonic 1. Sorry if I said the Sonic 2. It's the I meant the second zone of Sonic 1. Anyway. And then here the second param is going to be the path. So here it's going to be under the graphics folder. By the way, this is something specific to Vite, is that when you put your assets in the public folder, it's going to basically make sure that you can actually not need to specify public/graphics. You can immediately specify the path here as if it were at the root level. So this is something to keep in mind. So that's how I can just start from the graphics folder rather than saying, okay, we need to go to the public folder and then the graphics folder. So this is something specific to Vite. So here in the graphics folder, you just type in the name. So chemical-bg.png, which is the image. So this is something we're going to do for the platforms as well. So I'm just going to copy and paste that code that as well. So we have two assets. Now, how do you load sprite sheets? So this is something that you might ask yourself. So sprite sheets, to be clear, this is a sprite sheet. So it's an image that contains multiple frames, multiple sprites, and you want to define the animation. So usually here we have two rows. One is the Sonic running animation and all of its frames. And down below is the Sonic jumping animation and all of its frames. So you need to tell Kplay how this image is going to work. So this is how you do it. So you use the load sprite function. You give it a name. So I'm going to call it Sonic. And the path to find these the sprite sheet. So sonic.png. Now you have an optional third param that you can use for specifying the animations. So what you need first is to specify slice x. So slice x here is the number of frames in a row. Here we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 frames. So you specify slice x as being 8. As for slice y, it's how many frames per column. So here we have 2. So as I said, slice x is how many frames you have per row. Slice y is how many frames you have per column. Here per column we have 2 frames. And this is how Kplay will know how to split your image into frames, basically. And now the third property here in the object you pass as the third param of the load sprite function is the anims, and this is where you will configure your animations. So we have 2 animations to configure. We have the run animation, and then you have to specify from which frame, from frame 0 to frame 7. So here we have the run animation, which is going to be from frame 0 to frame 7. How do I know this? By default, when you split your animations, when you tell Kplay how to split your your sprite sheet into frames, the first frame is always numbered 0. And then you go from left to right and then downward. So 0, 1, 2, 3, 4, 5, 6, 7, and then 8, 9, 10, 11, 12, 13, 14, and 15. So from 0 to 7 corresponds to the first row of our spreadsheet. So here I'm going to also specify whether or not I want the animation to loop. And I want it to loop indefinitely until we stop it ourselves. Now, the last thing you need is actually defining the speed. By default, there is a default speed at which the animation will play if you don't specify this. But I prefer to specify for this game. I thought 30 frames per second speed looked good for this game, since Sonic's going to run really fast. So here we go. Feel free to play with those values though, if you think that another value looks great. And then here it's the same principle, so I'm just going to copy and paste it from my original code base. So jump, it's a name I've decided to name it this way. So here you decide on the name. So if you want a name that has more than one word, you just do run and then dash something. That could be a good convention. All right, so here speed is 100. This is when the Sonic jumps, and it's from frame 8 to frame 15. All right, so now that we have this defined, we're ready to basically do the same thing for the ring and also the Motobug. So here I'm just going to copy and paste the code and explain it. So if you look at the graphics, so for the ring, it's only a single row. If you remember, if I went to ring.png, you can see that it's a single row of how many frames? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 frames. So 15 frames. Is it? Yeah, 15 frames. So that's why, actually no. 0, 1, 2, 3, okay, because I started counting at 0, so it's 16 frames. So you specify that there is 16 frames per row, and there's only one row. And you specify an animation from 0 to 15, and then you loop it, and then you decide on speed. So now that you have that, same principle for the Motobug. As an exercise, try to understand how to do it yourself. It's a single line, so that means, 5 frames. So slice x is 5, and slice y is 1, because there's only a single row, a single frame per column, sorry. Well, actually, there is five frames per row, and how many frames per column? There is only 1. So here we go. And then here again, I just define an animation. So now that we have all of our sprites loaded, it's time to load other kinds of assets. So how do you load fonts and sound? So for fonts, you can use the load font if you have a TTF or an OTF file. You specify the name you want to use for that font as the first param, and as the second param, the path where to find this fonts. And here it's going to be in our fonts folder. So here the fonts folder contains a single font called mania.ttf. Now for sounds, it's really the same logic again, but using the load sound method or function. So I'm just gonna copy and paste the code here, and then feel free to keep the exact same names for each of the sounds that I've decided to use so that you don't have errors later down the line. So here we go. Now we have everything we need here. Now it's time to define our scenes for our game. So in the original game, I have multiple scenes. So let's take a look at them. So if I go here to the Sonic themed and I restart the game, so I refresh my page, click on run, I have first a disclaimer scene. So in this tutorial, I'm not gonna teach you how to make this scene because it's not really that important. The reason I put it here because we are making a Sonic, not a Sony, a Sonic fan game, and you know Sega owns the rights to Sonic. So one of the reason I decided to make a tutorial on how to I decided to make the game in the first place is that Sega is usually more permissive in terms of making fan games as opposed to Nintendo. So so here when you click, you have our first scene here. There is a reason why you should always have a scene before your menu, your main menu if you're playing sounds, or a scene actually, when making web games, you should have a scene before any sounds is played. Because the way the web works is that no sounds is going to play unless there's a first interaction by the user. So that's why, as a trick, you can see other libraries making a loading screen and then you have to click on a button to play the game. But here I prefer not to have this. I prefer to decide what to show the user, where to click, etc. So that's why if you want to put a lot of sounds in the menu, you should create a scene before that tells the player to either click or do something to arrive to that scene. Here in our case, most of the sounds, all of the sounds, are going to be played in the actual game and not in the menu. That's why it's fine if we start by making the menu itself instead of the disclaimer screen. All right, so if I press, here you can hear the sounds. All right, that's a nice combo. Anyway, so let's do that. So let's create a folder that is going to hold our scenes. I'm going to call it the scenes folder. By the way, just to teach you how it works, scenes work by calling the scene method in Coplay. You specify the name of the scene you want to use. So let's do the groundwork here in main.js before going to the scenes folder. So here in main.js, we are first going to have to create our main menu scene. I'm going to give it the name of main-menu. And the second param is the code for that scene that is going to run when this scene is activated. So here I'm going to keep it an empty function. Now I'm going to define another scene, which is going to actually be the game. And again, I'm going to keep it empty for now with an empty function. And then finally, I'm going to define a game over screen, which will display the score. And again, I'm going to leave it empty. Now you have to, when you create those scenes, if you should always use the go function to define the default scene. So you can go to that scene by just passing in the name. So let's go to the main menu. So for now, nothing should happen visually. Everything is black. So now let's go into our scenes folder and create a file called main-menu.js. So in main menu, we're going to import our context so we can have access to Coplay functions. And I'm going to create an export default function that is going to be the logic that is going to run when we call the scene. So main menu function. So if I go back here, I can remove this and type in main menu, and it's going to import it from our scene. from our scenes folder and scene main menu file. So by the way, I'm just passing the function name and not calling it. You don't want to call it. You want the scene function to be the one responsible for calling the function. So you don't pass in the parenthesis, otherwise you're calling the function immediately instead of when the scene decides it's appropriate. So here, what I'm going to do is I'm going to first define the best score. So the way Play has a very easy way to work with local storage, and in this project, using local storage is going to be very helpful to store the best score and the current score of the player, mostly the best score, so that you can compare and give the player a rank, and so they can have a element of progression in the game. So here I'm going to have an if statement, and if k.getData is the function you use to get some data from the local storage, and I'm going to use this key. Now, for now, it doesn't exist, so that's why I've put it within an if statement. Because if this doesn't exist, I'm going to use the setData function. All of this comes from Play, and set the best score here to 0. So now this should work. Okay, so now this if statement says that if the best score data doesn't exist, this is because of the bang sign here, which reverses the expression, then create the set data, then create the best score, key, and store it 0 with it. All right, so now another thing we're gonna set up is use the on button press event handler to, when the player press jump, we want them to go to the game. So you can do that like this. So on button press is an event handler. It takes as the first param the key you want to listen on. When this key is pressed, it's going to run the function that is passed as a second param. So here it's going to call the go function with the game key, and it's going to change the scene towards the game scene, basically, where the actual game is. So now let's hold a constant. Let's create a constant called background piece width. And the reason I'm doing this, so I'm going to use that to basically know when to swap the background, the first piece of the background. So the way infinite scrolling is going to work is by taking the same image twice, sticking them together, and once the first part of the image is off the screen to the left, we're gonna replace that image, this first part, behind the second part, and the second part is going to become the first part. So what was once the part 2 is going to become part 1, and what was once part 1 is going to become part 2. And by swapping in and out like that, we have an infinite scrolling effect. So if I go const background pieces, it's going to be an array, which is going to hold 2 sprites. So in Play, you create game objects. So game objects are the way you create entities, etc., that are going to be visible. There are other ways. You could just decide to draw things using the onDraw method, but game objects are useful because they come with, you can use components on them. So one of the main draw of Play is that it offers a lot of components that have ready built functionality for you, and you compose your game objects by adding components to an array. So the way you create a game object in Play is by using k.add. It will add a game object to a scene, and it will create it from an array of components. Those components are offered by Play, and they come with a bunch of features. So the first component we're going to use is a sprite component, which will take the sprite you want to display. So here you pass in the key. So if you remember, in main.js, we decided to name the chemical background to being this key. So what you do is you just take that key, and in main menu, you just call it here. And this is going to create a game object with this sprite. Now, we're also going to use the positional component called pos, which allows us to determine the position of a game object. And also, By using certain components, you will have in the resulting game object access to certain methods that will allow you to do certain things. So think of components like new abilities that you add on top. You stack on each other, and it gives you new functionality for your game objects. It's a very cool way of making games, and this is why I like play a lot with this concept. So here I'm going to specify the position to be at coordinates 0, 0. And now I'm going to also add the scale component, which will scale twice here, twice our game object. So our image is going to be twice as big. This is what looked good. Yeah, this is what looked good. So you're going to see in an instant. So we have this, and then I'm going to also determine the opacity. So I can use the opacity component and set it to 0.8, which is what looked good again. So opacity is a component offered by Coplay, scale is a component offered by Coplay, etc. So how do you know what components are available? Well, you can go to the documentation on caplayjs.com. So this is our first game object. Now we have a second one, which is going to be the exact same as the first one, as I explained the principle of having two pieces that follow each other, and then when one is off screen, we put it back behind like a train, and this gives us our infinite loop, infinite scrolling. So here I just copy and pasted the same exact game object, so it's going to be two game object with the same properties, same components. But here for the position, instead of having 0 here, I'm going to put the background piece width here, which corresponds to background piece width. Now here, actually, you know what? Since we're scaling twice the image. So by default, our image is of the resolution 1920 by 1080. But since we're scaling it twice, that means it's going to be twice as big as that. That means the end of our image is going to be farther along. So here, if you want our second game object to be right after the one, it needs to be twice at the position background piece width twice times 2. So that so the first image is set at 0, 0. So by default, when the game starts, and if the background pieces don't move, the first image is going to take the whole canvas, because if you remember, the canvas is 1920 by 1080 as well. So it's the same resolution as the chemical background. But if you want to place the second image right behind the image, you need to place it in such a way that the coordinate, the starting point of the second image is going to be after the first image. After first image ends, which is its width times 2, because we have scaled it twice. That means that the background image is twice as long as it normally is. So here we go. So, and also by default, something you need to understand is in game dev in general, things are drawn from their top left corner. So when you do position 0, 0, what is at position 0, 0 is the top left of the sprite of the image. You can decide, you can change the origin, but you need to use a component for that, and we're going to actually use one for other sprites. All right, so we have this. Now let's look at the result. I think it should look good. So yeah, let's test it out. Okay, so we have an error. So I'm gonna press F12, look at the console. Do we have an error actually? Okay, yeah, I guess it's not an error because I clicked. And if you remember, if you click, it's going to bring you to the game. So this is the background. Now I have some doubts because in my original code base, I actually kept the same 1920 thingy. So for the position. So yeah, maybe, you know what? I'm gonna put it as background width for now here. If we don't have any issues, that means that it doesn't matter in the end, because by the time the background is, well, actually, I don't understand why anyway. Okay, we're gonna see later on when we're actually going to implement the scrolling background. Okay, so now it's time to create another array like this with two game objects, and it's going to be our platforms. And much like our backgrounds, it's going to be replicated in the exact same way. So we're going to have a first game object, which is going to have a sprite called platforms. If you remember, that was the name we decided on for the platform sprite. So if I go here, go to main.js platforms. So now here, the other components we're going to use is a position. So I think the width of the image. So if I go here, platforms. Yeah, so let's put our first image, our first platform, the first part. Oh, let's put it at 0. Okay, pause. 0. And then for the height, it's going to be 450. So in game dev in general, the coordinate system is inversed. That means the farther you go down, the higher the value of y. So 450 is really at the bottom, towards the bottom of the screen. And now here I'm going to scale the image 4 times. So if I just do that and look at the result, you can see that we have our platform here. That looks nice. Now, again, the same logic we're going to use to have scrolling backgrounds. We need to add a second game object. This time around, this game object needs to be after the first one. And here, I think the way I did it... Okay, I think I understand why here I didn't multiply it by 2, because later on, we're going to anyway set the position per frame. So the starting position will not matter, because we're going to use an update loop, which is going to run any frame, any single frame, and 60 times per second, and it's going to modify the position. So that's why. So if I'm just going to multiply it by 2 just to be correct, but I think you need to multiply it by 2. And then here for the platforms, I think the same logic applies. Here, however, here I put it at 3. You need, actually I didn't, what's the width? The width of the image. So if I go to main menu, where is it? Maybe platforms. Okay, it's the width of 120. Okay, 1280 by 160. That's the width of the image. So I'm just gonna do that as well. So maybe have a constant platform width 1280, and then I'm just gonna put it here. But it scales 4 times, so if you multiply this by times 4, because we're using the scale. Okay, let's look at the result. Okay, for now it's not, I cannot really identify any issues for now, so let's work on the scrolling background and then we'll see. So before adding any text, etc., let's create our update loop, which is, as I said, a function that is going to run every frame, and usually 60 frames per second, 60 times per second, if you have a frame rate of 60 frames per second. So here in this onUpdate, what it takes is a function that is going to run every frame. Now here, what I'm gonna do is, if the background pieces, so that was the array we created, we're gonna take the one at index 1, which means it's the second one. So we check the speed, not the speed, the position. If it's inferior to 0, that means that the second background piece has gone below 0. That means has gone a bit too far to the left, outside of the bounds of the canvas. That means that we can take the first background piece and put it behind. So here again, if you want more visual explanations, etc., I have the article, the post I've made. I think it does a good job with schematics to explain. So if you want to reference this in the future, you can just go to the article instead of having to rewatch this video. So here, I'm gonna, in that case, when the second part is going out of bounds to the left, that means we can take the first part and we can use the move to function, and set its position to the position of the first one of the second, the second image, pos.x plus background piece width, as I said, multiply by 2 because remember we scale it twice. And then for the y coordinates, we don't need to change anything. So now what we do here is we are simply going to change the order of our game objects in our array so that what was once the first game object is going to be the second part, and what was once the first part is going to be the first element. So to do this simply in JavaScript, you can use the array methods. So the push array method, and then within the push array method, you can use the shift array method. So I'm going to explain what each does in case you're not familiar. So push will add whatever is within here as the last element of an array. Not as the last, we'll just add it to the end of an array. And then here shift takes out the first element of an array and returns it. So what we're doing here, we're taking the first game object and putting it at the end, etc. So now that we have this, we can have our logic to move our background pieces to the left. So we're going to do move. So the move method allows you to move a game object, and you can specify an x velocity and a y velocity. The x velocity I'm going to use here is 100 minus 100, so it goes to the left. And what I'm going to do here is for the second piece, it's going to follow in the footsteps of the first piece. So it's going to move to the background pieces. So the first one, the first element. So we're going to take its position.x. This time around, we also need to do plus the background piece width multiplied by 2. Like that. So now everything should work. Let's look at the result. We should have an infinite scrolling of the first background. So here we go. So things are scrolling infinitely. If I not press F2. So if I refresh, I press the D button, which I specified as my debug key, you can see the skyscrapers moving. So if you want to actually see when the first image starts off and where the second finishes, or vice versa, you can go here and add an area component. So an area component is usually used to have a hitbox. So I would not recommend keeping it here for performance reason if you don't need it, but it's really helpful to see the shapes of our images and sprites. So if I do here, if I refresh, if I press the D key, you can see that this is the first image, and at one point it's going to end, and you're going to see the line, the blue line is going to go vertically. So let's wait a bit more, and then okay, is it going to scroll? So the speed is a bit too slow. So you can actually see here the end of the first background and the start of the second one. So here we go. Okay, so let's remove the area components because we don't need it. So now we're going to perform the exact same logic we did, but for our platforms. So here again, I'm just going to copy and paste those things. So here we go. So here I'm going to copy and paste it. Now there's something I need to explain here. Here it's called game speed, but this is not necessary. So let's give it a speed of minus 4,000. It's going to look really fast. So if I go here, you can see it is infinite scrolling at a faster rate, and this is what we call the parallax effect. So when in the background it scrolls slower than in the foreground, it gives this effect of depth, which is really nice. All right, so now what we're going to do is to add Sonic. So let's create a folder where we will have all of our codes for our entities. So I'm going to call it entities, and one of the entities in our game is Sonic. So I'm going to create a sonic.js file. So what happens now is a pattern I like to use is to have a function. So I'm going to export a function. So I'm going to create a function which is going to basically act as a constructor. It will construct our Sonic game object. So I'm going to call it make Sonic, and make Sonic is going to take a position param. So position param is going to be a vector2. A vector2 is a data structure offered by Kplay, which allows you to pass in an x and y value at once. So you're going to see it in action in a moment, and it's going to be very clear. So here I'm going to create a constant. I'm going to call it Sonic, and I'm going to use again the add function, and then an array, which I'm going to pass in a bunch of components. So the first component I'm going to use is Sonic, and as the second param, optionally, we can define the default animation. So by default, I just want Sonic to run, to use the run animation that we specified in our main.js file. Now here I'm going to call the scale. So I'm going to scale the Sonic sprite 4 times because this is what looked good. I'm going to add an area component to Sonic to have an automatic hitbox for Sonic. You can specify the shape of it if you don't like the default shape, passing an object here. So here you could do shape and then passing an object. Feel free to watch my Kplay crash course where I go over this, or watch my previous tutorials, or go to the docs. But for this project, we're not going to really need this here. Actually, I think for the enemies, we're going to need to specify custom area, so you might not need even to look at the other tutorials. By the way, if you enjoyed the content, the tutorial so far, feel free to subscribe and like, and even give a review of the tutorial, of the course, if you liked it or not, so that it can help others know if it's worth investing their time into this tutorial. Thanks for watching, by the way. So here I'm going to use the anchor component. The anchor component allows you to change the origin of a game object. If you remember earlier, I told you that by default, things are drawn from the top left corner. So a game object is drawn from the top left corner as well, the sprite. If you want to change that and you want the character to be positioned along the center of it, you need to use the anchor component and specify center here as a string. And then here I'm going to use the positional component. I'm just going to pass the positional vector 2, which you're going to see in action in a moment. And then finally, I'm going to have, for now, there's nothing else really that's needed. So what I'm going to do is, actually maybe there is. So you know what, let's keep it at that. Let's go back to our main menu scene. And then in our main menu scene, what we're going to do is right before our on update loop, I'm going to call make Sonic, which is going to import it from our Sonic.js file. So make sure this is how it looks like at the top. Usually, maybe it's the best practice to have always the context on top, and then later on all the other things. This is something really up to you. It's a convention. You can decide on how you'd like. So here I'm calling make Sonic, but I need to specify the position of Sonic. And this is where you can use the vector2 data structure by calling k.vector2 and passing in the x and y value. So 200 by 745. This is what looked good. If I look at the result, you can see k is not defined in kplay.ds. Okay, why is that? That makes no sense. Okay, what do you mean? Make Sonic. Oh, in our Sonic.js, we're using the k here, but we haven't imported it. So we need to do import k from Kplay context. So now, if I go back to main menu, if I go back to look at the result, you can see Sonic running. All right, so yep, we have our main menu basically done. Now we need to add a bit of text, and then we're ready to actually tackle the meat of the game. Okay, so what we're gonna do here is right before, maybe here, before calling Sonic, let's create a game object with the sole purpose of displaying text. So yeah, in Kplay, even if you want to just display text, you need to create a game object and then use the text component. And then here, I'm going to call it Sonic Ring Run. So maybe if this could get away. And then here to decide on the font, you pass in as a second param, an optional param, an object with a key font. And then the font is going to be Mania. And then the size we're going to use, maybe if this could go away. So what is going to be the size? 32 should be good. So just pass in 32. Now, this is not enough because by default, if you do this, it's going to put it at the top left corner. Sonic Ring Run, which is not bad, but this is not what we want. What we want is actually for this to be bigger. So the text should actually be bigger. I think 32 is too small. So let's go with 96. And then let's add the positional component so we can specify a position. And in Play, you can call k.center to have the center of the center position of the canvas. So if you pass k.center, it returns a vector2, which is going to be able to use as a position. So if I go here, you can have Sonic here. Now it might look strange, like why is it to the left and not really to the center? Because if you remember, if I press the debug key, which I decided at the beginning of the project to be D, oops, I shouldn't have done that. I should do this, press D. You can see that the origin is the top left corner. And you can see the hitbox. So that looks nice. So if I go and press D again, it's going to disappear. So if we want Sonic to be at the center, if you want the text to be drawn from the center, you need to specify the anchor. But you know what? Actually, you're going to do that. So if I do this, I add k.anchor, specify the center. I look back at the result. You can see that the name Sonic Ring Run, which is the name I decided for the game, is at the center. If I press D, you can see that the dot is at the center. All right, so now what we need else, is to actually change the position so that the title is at the center X coordinate, but for the Y, I want it to be at 200. So to get a one of the specific coordinates, either X or Y, you just do .x once you have a vector2. So I do this, and then if I look at the result, now it looks nice. So now we're going to add a second game object. This time around, it's just going to tell the user what to do, to press space or click or touch to start the game. So here, I'm going to add it like that. Here, I just copy and paste it from my original code base just to be fast. So you have the press space, click, font using the Mania font, and size 32. And then for the X and Y coordinate, what felt good was taking the center Y and then subtracting 200. And remember, when you subtract, when you go, the value of Y gets smaller, you actually go up. When the value of Y gets bigger, you go down, which is an inverted, Cartesian plane, which is not common outside of game dev. All right, so now if I look at the result, you can see our main menu is done. So now we're ready to tackle the actual game. So I'm going to close main menu.js. I'm going to go to I'm going to create a new file. In the scenes folder, I'm going to create a file called game.js. I'm also going to take the opportunity to create a gameover.js file. And I think we should have our 3 scenes. All right, so for game.js, I'm going to export default because it's going to be the only thing we're going to import from this file. I'm going to call it game. And it's going to contain the logic for our game. Remember, since we're going to use a lot of K here, I'm going to import the context as well. So here, what do we need? So I'm going to first set the gravity of our game. So the reason I'm going to set the gravity is so that I'm going to be able to jump later on. So here the gravity value I chose is 3,100, which is what felt good. So in Play, you can set the gravity of your game by just calling set gravity. Now that doesn't mean that the gravity will do anything if you don't have game objects that have the body component. So we're gonna look at that. We're gonna add it to Sonic in a moment. So because he's going to be affected by gravity. So here again, it's the exact same logic for the scrolling background. So I'm gonna copy and paste it here. Now you could, if you wanted to have proper programming practices, to, not copy and paste, create a modularized function and use that. But this is a pretty small project and we're just going to copy and paste this once. So you might not want to bother, and I didn't want to bother with this. So I'm just gonna copy this though, and I'm just gonna paste it here. And I'm gonna use it here. So platform width. So this logic is the same. However, there's going to be a little bit of nuance. So here we have our two pieces as we discussed in the main menu.js file. However, what we're going to need to do here is different, because we're going to have to create a game speed variable. So here, let's do it here. So we have a variable called game speed, which starts off at 300. Because remember, the mechanics are, as you play, the game gets progressively faster, and we want the platforms to scroll faster to give that sense of speed. And by the way, a trick is that Sonic is actually stationary in this game. We just give the impression that he's moving by scrolling the background instead. So that's the secret, I guess. And then here, I'm going to use the loop function to every 1 second. Here you specify the time in seconds. It's going to fire this function. So here, every second, it's going to increment the game speed by 50. This is what looked good. And then here, if I go downwards, if we create our onUpdate loop, so k.onUpdate, like I explained earlier, it's going to run the function here every frame. So here I'm going to copy and paste the logic we had for our background. So this remains unchanged. You could decide to have this in a modular piece. And then for our platforms though, things are going to get different slightly. Now, here we go. Now, there's one thing I did here which was pretty smart, is to use dot width. So you can get the width of an image by having dot width. So you might not need to have BG piece width. You might need to store it. You might not need to store it. So you know what? Since I've already brought the platforms width constant and it is shorter, I'm just gonna use it here. So here, remember, multiply by 4 because we scale 4 times the platforms when we created the game object for that. Here, you can see. So now here, the game speed is by the speed we were going to move the first platform, which the second platform is going to follow suit. So now, as this increases, the game will get faster. So now if I look at the result and I refresh this, click, okay, nothing happens because we haven't hooked up the scene first. So we have the function, but we need to actually go back to main.js and hook up the scene. So to hook it up, we're just going to replace this with game and import it from, remember, from our game file, from my game file. So now if I hit the save and I go back to look at the preview, I click, you can see as time will pass on, this is going to get faster. So let's just, let's see how fast it gets. So you can see speed is starting to pick up, and it's going to pick up, etc. So 50 is a value that incrementing by 50 makes sense here because it's not too fast of an increment that it goes from 1 to 100 too fast, but it's a good value so that it progressively gets faster and faster and faster and faster. So you can see actually it's getting faster. So I'm not gonna, waste too much of your time now. So let's actually work on getting Sonic here. So let's close main.js. Let's go to game.js here. And now we're gonna have to do a bunch of things. So first of all, right before maybe the loop here, I'm going to create our platform. but not the platform that we saw, the sprites, but an actual rectangle that will act as a platform for Sonic when Sonic is going to be affected by physics. Because if you remove away all the sprites, what really happens is we have a box that represents Sonic that jumps stationarily on another box, which is the platform that doesn't move as well. So we need to create a game object for that, and it's going to be invisible. So here we're going to use the rectangular component, rect, give it a width of 1920 by 3000. I'm going to give it an opacity of 0 by using the opacity component, so it's invisible. I'm going to give it an area so that it's going to have a hitbox. I'm going to give it a body component, which will make it susceptible to gravity. And if you pass to the body component an object with the is static property to being true, it's going to make sure that this body is going to remain fixed. So that means it's actually not going to be affected by gravity. It's going to be like a wall, an obstacle. And finally, I'm going to pass in a tag. Well, actually, I don't think I need this tag here. You're going to see that tags are pretty useful when it comes to detecting collisions. So it's just a string that you pass in your array of components. It's not a component itself, but it's very, very handy. So let's run this. So now if I, whoops, cannot read property of undefined clone. What do you mean? Okay, did I do something wrong? Okay, add rectangle. Okay, opacity, area. Oh, okay, we need a position. We need a position, so we need to specify the position. So the position that was nice was 0 by 832. Don't remember to add your commas. So now here, if I press, you can see if I press the D key, which is the debug key I specified earlier, you can see that there's an actual stationary rectangle. It's not maybe not really visible. That doesn't move. That is this box here, which acts as the platform. So now we have this. We can actually start spawning Sonic. So Sonic is going to come. Let's put it right here. Let's do const Sonic, and then we're going to, oops, we're going to call the make Sonic method, and then pass in the position. So the position that looked good was 200 by 347. I think it's the same that we used in our main menu. Let's look it up. 747. Okay, 747. Okay, 7, like that. Now if I look at the result, and there's an issue. Make Sonic is not defined. Okay, that's because we haven't in our game.js imported the make Sonic function. Make Sonic. Here we go. If I hit save, remember to hit save, click here, you can see Sonic is here. Whoops, I always press the F1 key here for the debug mode, but here on Edge browser it doesn't work well because it opens up a page. So here D key, you can see that we have our object, our Sonic. Now there's an issue here, is that Sonic isn't doing anything. So let's go back to our sonic.js file, and in sonic.js file we're gonna actually write the logic to make Sonic jump, and not all of the related logic, but a lot of it. So here in Kplay you can also pass in your array of components an object which can contain extra properties you want, custom things. And you can also pass in, you can also use the fact that you can pass an object to define methods for your game object. So it's a bit like OOP, object-oriented programming, but without having to create your classes. So here I'm going to create a method called setControls, and you can do this like that. So you might not be aware of this syntax. It's equivalent to this. but it's just a shorthand. So here in set controls, what I'm going to do is I'm going to call on button press and specify when player jumps. We want to, if this, so this here corresponds to the game object, so Sonic in this case. So this is something handy when you define your methods here, is that this gives you access to all the other properties and methods you define within the object and even outside of the object, because the the components here that you add will add certain properties and certain methods. So you will have access to them here by calling this this dot thing. All right, so this dot, and then is grounded is a method that is available if you use the body component. So we actually didn't use it, so we need to actually use the body component here. So I'm just going to add it, so it's going to make Sonic susceptible to gravity. And now because I added this, it allows me to use this. It offers this method. So this method is going to be available on that object, on the game object, because I used the body component. So is grounded basically tells us if Sonic, or the game object, is on the platform. So is grounded basically. And if it's the case, we're going to first play the jump animation. So you can, since we are using the sprite component, we can have access to the play function, the play method, which you can use to specify which animation you want to play. And we want to play the jump animation. So this play.jump is going to play the jump animation, sorry. And then this dot jump, however, this is something that if you have the body component, which we have here, is going to make the game object jump. So actually jump physically in the game. So this allows you to not have to implement your own jump mechanic, and you can specify properties here like the jump force. But for now here, let's define the jump force within the body component. So you can pass in optionally an object that is going to define by how much the game object will jump. And here I thought what looked good was a jump force of 1700. All right, so now the last thing we need to do is actually to play the jump sound. And here this is something that might confuse you, because k.play and this.play are not the same thing. This.play is the game object.play, so it's a method of the game object, which plays an animation, while k.play plays a sound. It's a global thing from kplay. So be careful with these two, it's not the same thing. So this is for playing sounds, this is for playing animations. So here the sound I'm going to play is also called jump. So if you remember when we copy and pasted from our in our kplay main.js file here, when we imported the sounds, we decided that the jump sound was this one. So here in the Sonic is going to play the jump sound, and here, because by default the sounds are too loud, you can specify as the second parameter object with the volume. So that's cool. And I'm gonna set it to 0.5. So it's from 0 to 1 and defines how loud the sound is going to be. And 0.5 is what looked good, sounded good, without being too loud. All right, now that we have this, we can define another set events method. These methods are just arbitrary. It's the name I've decided to call them like that. They don't do anything, like you could have called them whatever else. So here in the set events, I'm going to use, again, this to have access to the game object methods. And there's a method called onGround. So what happens is when this onGround, like the doc says, the doc disappeared. So dot onGround. So we click here. Okay, maybe if I do this. Okay, here. If you have the body component, you have access to the onGround event listener, which is going to register an event that when the game object hits the ground, then it's going to fire the function you pass as a param. So here, I'm going to pass an error function that is going to run this.play run. So basically what this does is when Sonic has done jumping and hits the ground, it's time to put back the run animation. So now that we have this, I can go back to my game, and right below Sonic, I can call these methods. So I'm going to call set controls so that the player can start jumping, and I'm going to call Sonic.setEvents so that the event listeners can start listening. So the on-ground event listener. So now if I go back and to my game, click. Okay, there's an issue. Cannot read set controls. Okay, why is that? Did I call it set controls? Set controls. Okay, did I save it? What's the issue? If I go here, hit save. Normally this should work. Okay, so that's strange. Okay, cannot read properties of undefined reading set controls. Okay, why does it think it's undefined? So here we go. So on button press. And that's strange. That's very, very strange. Okay, let's use another name just to test things out. Let's just use another name. So let's the name like set jump, like set jump mechanic. Let's call it this way. Let's go here. Set jump mechanic. Now if I hit here, okay, what's the issue? Set jump mechanic, reading property of undefined, reading set jump mechanic, cannot read properties of undefined. Okay, there's something missing. If I go back to Sonic here, do I have all the correct components? Scale is here. Anchor is here. Area is here. Position is here. Did I pass the correct position? I did. Oh, okay, I know why. I did not return Sonic. Because later on, we're going to add a child game object to Sonic, which is going to be its counter. When you jump or collect a coin, you're going to have a +1 near Sonic, and it's going to be created as a child of Sonic, of the Sonic game object. So here, I forgot you need to return Sonic here. And here, so that means we can just call it set controls as well, so it's not an issue of names. So if I go here, call set controls, and now hit check the game. Here we go, and then you can jump. So if I open the debug mode, you can see Sonic jumping like that. So this is something like we already have one of the big parts of the game done. So what we're gonna do now is create our mobs, basically, our enemies. There's only one type. It's the motobug. So I'm gonna call it, create a file in the entities folder, call it motobug.js. And then motobug, the way it's going to be created, I'm just gonna copy and paste it. So what I'm gonna do is here I'm gonna go over each of the components. So here we export a function, should have maybe, yep. Here you might ask yourself why you're not using export default since it's the only thing. I'm thinking that if you scale the game further, you might maybe define a few other functions here in this file. So that's why I didn't use that. So here make motobug is, again, it's going to take the same pattern of using make and then the name of the entity you want to create and then a positional param, and then it creates a game object and returns it. So it returns the game object with the following components. So the sprite component with the motobug sprite and the anim run by default. And then here it creates a custom shape. So instead of using the default shape, it's going to create a new shape by using the rect constructor from Kplay. So you need to do new k.rect. And then the first param is the offset. So here it's a position relative to the game object. So I want the the hitbox, the area, to be -5 relative in the x coordinate to the game object itself. This is what looked good. And 0 offset for the y coordinates. And I want the rectangle, so the area, the hitbox, to be of 32 by 32. And then here again, I scale this 4 times. I think Sonic, I also scaled him 4 times. Anchor center, so that the center of the sprite is the origin, which is easier to reason about for entities. And then the position here. And then here is the off-screen component. This is going to allow us to have access to methods to check when the enemy is off-screen. And it is going to be helpful because we're going to spawn a lot of enemies in this game, and we need to destroy them basically when they leave the screen. Otherwise, it's going to affect performance severely. And then finally, we have the tag. So a tag is a way to identify a game object. So I'm going to call it the enemy tag. So you can pass in as whatever string you want to use. And it's going to be used in the onColliders event listeners that we're going to see in an instant. So here we go. We have our make motobug thing done. So now we can go back to our game. And here I'm going to create the logic to spawn those motobugs and attack Sonic. So the way I'm going to do that is I'm first going to define a small little function called spawn moto bug. It's going to be an arrow function. The reason I'm doing this here is because really it's something that we're not going to use elsewhere. So for a little function like that, I usually use an arrow function like this because remember, arrow functions have access to, well, here it's not relevant, but it might be relevant in certain cases where you want a function that has access to the same context as the parent function. So this, you want it to be the same. And one property of the arrow functions is that they don't create their own scope, their own this. So they inherit the this from their parent, so from the function that wraps them or something like that, which is pretty handy. All right, so now here, but for this specific case, it's just to have a little piece of reusable logic. So not really reusable logic, but just self-contained logic. So here I'm gonna create a motobug. So what this spawn motobug does, it first creates a motobug by calling the constructor that I defined, and then it's going to place it at 1920 for the x coordinate, or maybe 1950, so it's not visible at the right side of the screen at first, with the 773 as the y coordinates. This is what looked good after experimenting. So if you're wondering how I came up with those values, it's just trial and error. Now here for the motobug, I'm going to set an onUpdate loop for it. So this is something you can do in Kplay, is you can have an update loop specific to that game object. So when the game object is destroyed, the event loop is also going to be destroyed, which is going to be good for performance, because you don't want an onUpdate loop that runs every frame to run even after the entity is dead. So for this, what we're going to do is if the game speed is actually we should have defined this, just, you know, let me remove that. Let's define it after having defined the game speed. So if the game speed is inferior to 3000, what we're going to do is we're going to actually make the motobug move to the right by a certain offset. So game speed plus 300. So it really looks like the motobug is going to the left and isn't stationary. So the move, the first param is the x velocity. By having it negative, that means we're moving to the left. And as for the y velocity, it's going to be 0. So what happens now is we're just going to return early in that case. But as soon as the game speed is superior to 3000, we stop moving. Well, actually, we still move the motobug, the enemy, but at the same speed as the platforms, the game speed. So it's at this point, it is basically stationary. And the reason I'm doing this is as the speed goes really far, the game speed increases a lot. It's going to be very difficult for the player to be able to dodge a moving motobug. So what I do is I basically make the motobug at those speeds stationary. They don't move basically. except they just follow the game speed. So they move at the same rate as the platform rather than a little bit more. So when you start the game, the plus 300 gives an impression that the motorbug is actually moving to the left while the platform is also moving. But at really fast speeds, we actually just move the motorbug at the same speed as the platform, and at that speed, it's not noticeable, and it makes the gameplay a little bit easier for the player. All right, so here we go. Now, as I said, I use the off-screen component so I can have access to the on-exit screen method. And what this on-exit screen method does is it runs a function when a game object that has the off-screen component goes off-screen, basically. And then here, you could go off-screen in multiple ways. So when we create the game object at first, it is off-screen to the right, but we actually want to destroy the motorbug when it is off-screen to the left. So here I'm going to have an if statement called motorbug pause.x. So this is how you access the position. So motorbug.pause.x. Sorry, I did not explain this earlier. I just took it for granted in the previous things we did. Sorry. So this is how you access the x coordinate. Now, if this is inferior to 0, we can call the destroy function in Kplay and pass the game object, and it's going to destroy it. And then finally, what we're going to do is we're going to set a wait time, which we can use the random function of Kplay, and you can define a starting interval and end interval, and it's going to give you a random value between those two. So between 0.5 second and 2.5 second. Here it's just numbers, so it isn't considered seconds until we pass them to the k.wait, so the wait method. So wait method takes a time in seconds that it is going to wait and then run a function. So here we're going to use some recursive a recursive function. So we're going to basically call the function itself within itself after a certain time. And this is how you get an infinite enemy spawner. So here we have everything. Now we can just call spawn motorbug. So now if I do this and look at the game, you can see for now nothing is going to happen because they don't do anything yet. So yep. So I can still jump, and now it's time for the logic to actually make Sonic vulnerable to them, and also make Sonic, not only vulnerable to them, but actually be able to bump on them as well to gain more rings. So the way we're going to do this is by using the onCollide. So Sonic dot onCollide. So the game objects have access to this method. It takes in as the first param the tag of the game object you want to check collisions with. So Sonic is going to collide with so onCollide is going to run when Sonic collides with any game object that has the following tag. So the tag I decided here is enemy. So this is for the motobugs. And when this occurs, it's going to run the function here as the second param. So this function, what it is going to do is going to first play, actually, if Sonic is not grounded. So in that case, which is a function, by the way, it returns true or false. So if Sonic is not grounded because of this, then I'm going to play the destroy sound at the volume of 0.5. I'm going to also play the hyper ring sound just to signify that the player has bumped into an enemy and is receiving more rings, basically. That's why the hyper ring sound. And then I'm going to destroy the enemy. Now you might ask how I'm going to get the enemy, since how do we do that? Well, actually, as the onCollide, what it does is that it takes the tag and it's going to pass the game object as a param to the function you call. So here, if you set it up, so choose a name for a param, what is going to be here is going to be actually the enemy itself, the game object with the tag enemy that has that collided with Sonic. So here it's going to destroy it. So there's two cases where the Motobug can be destroyed, either here or when they exit the screen to the left. So now that we have this, we destroy the enemy. Now we're going to also play the jump animation. So what happens in this case is that not only will Sonic destroy the enemy when they bump into it while they're not grounded. That means that they're jumping on top, or while they're jumping, they're hitting the enemy. So they're in their curve. Sonic is in his how we say, rounded, curved form. So what happens, I wanted gameplay wise that when this occurs, Sonic will gain an extra jump. So we're gonna play the jump sound again. Now here, play the jump animation, sorry, not the jump sound. Even I, sometimes confuse those play methods and functions. One is for sounds, and one is for animations. And the one that is for animations is the method of a game object, while the one for sounds is directly from k.play. So here we are going to have a Sonic jump, and then we're going to actually we're going to actually make Sonic jump using the jump method that does it for us automatically. Now there's a bunch of logic we can add later on, where we're going to add the scoring, multiplier, etc. Let's do this a little bit later. Let's see what we have now. Actually, before let's see what we have now, let's actually return early in this case, and if this is not true, that means Sonic hit an enemy while grounded. That means we need to play the hurt sound, so Sonic is hurt, with a volume of 0.5 to not be too loud. And then here we're going to set the data. So here we haven't written the logic for the score yet, so I'm just going to write a to-do comment here. And then here again, I'm just going to go to the game over screen in that case. All right, so now if I look at the result, play the game, jump on the enemy, and I bump out. Now if I hit the enemy, I go to the game over screen. Well, also I hope you hear the sound. If not, you should hear it on your side when you're following the tutorial. So yeah. All right, so we have a big part of the gameplay done. So now let's write the logic for actually getting the scores. So setting up the scores, and then we'll write the logic for the rings, etc. So actually, let's first spawn the rings. So here, the same logic as spawn Motobug. Again, this is something you could potentially find a way to modularize. So I'm going to leave this to you as an exercise. So yep. So I'm going to create a small little function called spawn ring. And in that function, I'm going to create a ring. And now here to do, yeah, I don't think it's valid code. So let's do this. Let's create in our entities folder another entity called ring.js. Now here, to be faster, I'm just going to copy and paste what I had. It's no new concepts, except that we have different animations and a different tag. That's it. If I go back to game.js though, and yep, if I go back to game.js, let's put the ring here back. Now here we can call make ring. It's going to import it upwards, so hope it did it for you as well. So remember to check, or otherwise you're gonna spend some time debugging without knowing and waste a lot of time. Here I'm gonna put it at 1950, and for the Y value 745, like the Motobug. And here again, it's the exact same logic, so that's why I said that you could write one function that does it for both the Motobug and the enemy. So feel free to do this as an exercise. So here, game speed, same logic. On exit screen, same logic. The only thing that changes is the time, the wait times, which I think you can modularize this. So I'm going to leave it to you as an exercise. It's going to be a good exercise for you. All right. But sometimes, when you're developing a game, you're not sure if something is repeating yet. So you purposely write verbose code just so that in case in the end, those two cases are not really the same. They cannot be modularized. In that case, you won't waste time by having like an early abstraction that you will have to disassemble because it wasn't the right fit. So something to think about. All right, so now if I call this spawn ring, it should spawn indefinitely because again, it's a recursive function. It calls itself every certain amount of time. So now if I go back here, press, and then you have rings. Now we don't have the logic yet to collect those rings. So let's write that. So here again, up in the, let's collapse this. Sonic on collide with the ring. Let's have the ring here. And then here. And then here again, there is some similarities. It's not exactly the same. Yeah, so here k.play, we're going to play the ring sound at a volume of 0.5. Then what we're going to do is we're going to actually destroy the ring. Again, remember, we have access to the ring game object provided by the onCollide event listener. Then here we need a score. So let's create, right above, or maybe, yeah, right above a score. Let score initially 0. And then let's also create a let score multiplier. And again, initially 0. So every time you bump, the score multiplier will increase. So here in the onCollide here, we're going to have the ring destroyed. And then here, I'm going to increment the score. Now later on, we're going to update the UI for this, create the UI for this. And then, yep, so let's do the next, the rest later on. By later on, I mean just probably the next thing we do, but just to look at the results. So here we go here. If I bump, it just died. So if I refresh, let's skip this one. Let's skip, okay, you can hear the sound when collecting the rings. So that means it works. All right, so let's add our logic for our scores, etc., the score text, etc. So right above, here, I'm going to create a constant. By the way, the source code is going to be available in the description as well. So if you want to compare. So here, controls text is going to actually be the text. Okay, we're going to need a score text first, and then later on we'll think about it. The controls text is basically the text in the beginning of the game that tells you to, click, touch, etc. to jump. Basically teaching you how to play. So here we're going to create a game object. And what we're going to do here, it's going to hold the score. And here again, nothing new. So I'm just going to copy and paste what I have and paste it here. So now if I look at the results, you can see that it's at the top left corner. So now if I go back to the ring logic here, after incrementing the score, what we're going to do is, here you go, do score text, which is the game object. You can access actually, if you want to modify the text of a game object after the fact, you have used the text component, you can have access to it by taking your game object dot text, and then you can modify the content by assigning something new. So here what I'm going to assign is score. I'm going to use a template string and then pass in as a $sign the actual score, the current score. So here, if I go back and skip this one because we haven't written the logic 1, 2, 3, etc. 4, 5, 6, 7, etc. All right, we have our score logic, basic score logic working. Now we need to add this core logic to the motobugs, the enemy. So when there's a collision with the enemy, So the way we're gonna do this is to basically have here. So after playing the hurt sound, I'm going to actually not here, here. What I'm gonna do is first always set the score multiplier to being +1. Score multiplier when there is before, you know. So when the Sonic jumps on an enemy the first time, it's just going to give you 10 rings more. But if you continue to basically bump on enemies one after the other, it's going to give you a multiplier. So it's going to multiply your score. So here, score plus equal 10 multiplied by the score multiplier. And then here's score text. Basically the same thing we did where we did it here. I'm just gonna copy that here. So now everything should look great, should look good. Let's see if it is actually working. So if I bump on, oops, if I bump on this one, +10. If I bump on this, okay, let's try a combo. So let's try to have a multiplier. So 10, 30, 60, 100. Nice. So now we need a little bit of visual indication, you know, because it's not enough. And also, what happens here is we need to actually reset the score multiplier to 0 when... Wait a minute, where did I do that? I don't remember actually resetting the score multiplier. Wait a minute, so let's play again. Let's say I have 1 and then 30. And then if I... Okay, we need to reset the score multiplier once you hit the ground. Otherwise, things are not going to work. So I think I did this in either the Sonic.js. This. Did I do it here or maybe... Actually, we should do it... So if you're grounded and you collide with the enemy, you do this. But actually want that if you're grounded at all, we need to reset Sonic. Yep. So here you're gonna add an if statement in our on update, and we basically going to do if Sonic is. So the reason I'm doing it here instead of in the Sonic logic is that we don't have access to the score variable. So score multiplier, gonna reset that to 0. You could have decided to do it elsewhere. Maybe you could have decided to store the current score in local storage and then call from the Sonic set events here the local storage with the current score and the current score multiplier, and then set it here. That could have been a pattern you could have decided to use. Alright, but this is a very simple game, so I don't think it's really worth it. Alright, so now what we're gonna do is actually go here and remember I created this constant as a Sonic constant as a way so that we can create a child game object later. So let's create this child game object. So the way you create a child game object is that you take a game object and you just add to it. You just call the add function on it, and it's going to create a child game object. So what is going to be the game object? So this is the usual way, but to have things more convenient and organized, we're going to create a ring collect UI property that is going to be null here. And then instead of calling the Sonic add immediately and just, because by default, if you do this, to access the children later on, you're going to have to do Sonic dot children and then array 0, etc., which is less convenient and less understandable. You will not understand it if you're not familiar with the code base at all. If you see this, so what I do is Sonic dot ring collect UI, and I'm going to store the child game object here as well, so that someone is going to understand. Here, the components I'm going to use are these ones. So first, an empty text with the following font and size, and then I can use the color component to have this text of a yellow color. So this is the RGB value for yellow. I'm going to put the anchor to being center, and then the position to be 30 minus 10. And this position, because what we're creating here is a child game object, it's going to be relative to Sonic. So these values are relative to Sonic. So now what I'm going to do here, it's going to be, let's first do it with the ring. So we have a score here, but we're also going to have the UI thing. So for the UI, what I'm going to do, when you collect a ring, I'm going to first check if the score, so if the score multiplier is equal to 1, I'm just going to put it a +1. Actually, you know what? This is not here at all. Anyway, we need to actually do Sonic ring collect UI and then text, and then have a +1 text, and then wait, after 1 second we will we'll remove the UI. So we aren't going to delete the ring collect UI game object. We're just going to set the text back to being an empty string. So if I go back and look at the result, I click here, and then here nothing happens, but +1 and then disappears, +1 and then it disappears, +1 and then it disappears. So for the enemy, the same logic applies here. If so, score Sonic ring collect UI, and then text. Then the text is going to be this time around the template string, because it depends, plus, oops, yeah, so plus, and then $, or actually here it's going to be different, because if by default it's going to be plus. So if the multiplier is a score of 1, so if we have a score multiplier of 1, we're just gonna have here +10. So let's just have a string. However, if, okay, let's just have a second if the score multiplier is superior to 1, then we're gonna have multipliers instead being displayed. It's going to be more understandable for the player than, you know, seeing 30, 20. You might not understand why. So here I'm going to use a template string, and then $, and then here I'm going to use score multiplier times 10, and then here an X sign instead, because it's actually, never mind, don't need to like that. Here we go. So now if I look at the result, I bump on this one, +10. Okay, you need to do it more than once. Okay, I forgot the logic to actually delete what we have here. So again, like we did with the rings, we need this wait thing, 1 second, and then we put it back to an empty string. So if I look at the result, I bump on this guy, and then, okay, let's try to have a combo so that we can actually see the multipliers in action. Okay, can we actually multiply by 2? Ah, okay, but you actually can see, you know, multiply by 2 and then 3, etc. So 1, 2, 3, 4, 5. Oh, that's nice. This is not a pre-planned, huh? It was a matter of skill, I guess. I'm just too skilled, I guess, to my game. Anyway, so here we go, and I think that's it. So here, when you hit the enemy and you're not grounded, it's game over. We're gonna set the current score using set data, so that we can have access to the current score in the game over screen. You could have decided to do this, or you could have access to it by passing it as a second param to the go function, which is going to take care of passing data from one scene to the next. But I don't really like it that much. I don't like to use it that much for stuff like that, for data. So we're gonna use it in this tutorial, but for sounds, because the one we're gonna have, you're gonna see in an instant. So what I'm gonna do is, okay, so we have the current score, and then here, what we're gonna do is I'm just gonna pass this the score, and then for now, that's it. Now I'm gonna add the city sound effects. So the ambiance here I wanted to add, and let's add it at the top of our scene, maybe right after the gravity or before, it doesn't matter. I'm gonna create a function, a constant called CDCF sound effects, and it's going to play the city sound with a lower volume because it's too loud, even louder than the other sounds. So that's why I need to put it to 0.2. So volumes can vary between 0 and 1, and I'm gonna loop it. The issue is that if you use loop true and you don't store your sound inside of a constant, that means it's going to play even outside of scenes of this scene. And that's why when you hit the game over screen, I want to be able in the game over screen to remove this ambiance because it doesn't fit. So as the second param of the go function, I'm gonna pass the city sound effect. By the way, this is a shorthand for doing this. If you want to pass it. So by just doing this, you can pass. So what I'm gonna do here is I'm going to go, now it's time to go to the game over logic, which is empty for now. Just to be a little bit faster, what I'm gonna do is I'm gonna go to game over, and I'm going to, you know what, let's type it out. So import k from Caplay context. Let's create an export default function game over, and here it's going to take the CD sound effect as a param. Now this is not very elegant, I think. So maybe it would have been better to, I don't know, have a global state manager, but I didn't want to overcomplicate this tutorial. So maybe in the future, we're going to make some more complicated games as well. So in that case, so you can actually watch the Zelda-like where I use the state management. I did something for state management in that tutorial, so you can watch that. So here the function, the game over function, what it does, it takes the CD sound effect and just set the pause property to be true. That way, it's going to not play. And then here we're also going to have a best score variable, which is going to get the data from local storage for best score. Remember, when you start the game, best score is created. So even if the best score is 0, it's going to be defined here. Then we're going to create a current score constant to get the actual current score of this run. It's going to again use the get data for this attribute we've defined in our game when you die, and the only way you can die in this game is if you hit the enemy while you're grounded. So here, current score is where we set the data for the current score. Now here, I'm just gonna copy and paste those two values, which is the rankings. I like to add rankings in arcade style games with a letter grade and then the rank value cutoffs here. So here you can copy and paste the code. Now, by default, we set the current rank and best rank to being both F. And then we have a for loop. Let me just copy here, just go a bit faster. So this for loop is going to iterate through the rank values, and then if the rank values dot I, so this specific rank value is inferior to the current score, then we set the current rank, and we also set the best rank at the same time. So this is how we do it. Now we could have use an easier for loop, I think. You could have used the easier version of the for loop. So that's something to think about. Maybe try to use the for const of. Maybe you could get away with that. Yeah, probably I didn't think of it when I was writing the code for this. And then now we need another if statement to check. So if the best score is inferior to the current score, we will set the best score to the current score. That means a new record was beaten. And we also need to swap the best score for the current score in this the variables, because we're going to display the results, so best rank, etc. So for next time, it's going to having set the best score to the local storage, but for this time, because we're still in the scene and we're going to display things, we're just going to use just going to also modify the current best score here and best rank variables. Then finally, one of the most tedious parts is the text for everything. So here I'm just gonna again copy and paste. So here, nothing fancy, just game objects with text components. It should be, yeah, it would be nice to have a easier way to have just text instead of having to create a game object like that. So maybe create a reusable function, call it make text or something like that. So yeah, something you can either write yourself to save some time later on. So here we have the game over screen, size of 96, positions here, anchor center, best score, current score, etc. And then finally, we're going to create two boxes. So we're going to have, first of all, a best rank box. So you're still within the function, a best rank box, which is going to be a rectangle with a radius of 4, and its color is going to be black. But the outline is going to be this. So you can use the outline component to find the outline and then the color for that outline. So the radius is how rounded the corners are. And then the outline can define the thickness of the outline, which is 6 here, and which color. It's going to be a white outline. So it's going to be a black rectangle with a white outline. And then we're going to add as a child of that rank box the actual text, so the rank itself. So same logic applies again to the current rank box. So this was for the best rank box, but now let's do it for the current. So here we go, and then here, typo. Same logic, just different positions. And then finally, we're gonna have a wait loop function, handler, which after 1 second will display the text to press, space, click, touch to play again, and will set the on button press event listener of jump to go to the game. This so you can restart the game. The reason I delay this by 1 second is that if you're playing, you might accidentally, as soon as you lose, click again, space, and it's going to restart the game immediately without letting you have the opportunity to look at your scores. So now that we have this, we need to go here to the, actually, we need to go back to main.js to hook up the game over scene. So here, instead of having the game over scene, actually, yeah, you can have it this way. So just call game over here and pass it here, and then game over is here as well. So now let's play the game. So if I try my best, +10, +10, +40. Let's try picking up some rings. You can hear the city sounds on your end, hopefully. Maybe the sound for my setup is not too loud, so you won't be able to hear it in the video. So I do this. Let's, okay, so +1. I think we have the, here we go, +10, +10, +10. So the current best score is 78 because it's the first time we're playing, and then press play, space, click, touch to play again. So if I press, and now if I try to beat my score just to show you the difference, +2, then okay, maybe I'm gonna beat my score. I think my score was 71 or 78, so I need to beat it just to show you the difference. So let's do that. I'm not a very good Let's Player, cannot think of conversation subjects while playing games. I'm trying to focus on the game. Okay, so now you have beaten our score. Actually, it's the contrary. I need to not beat my score. So let's die here. So you can see that best score E rank, current score 0 F rank. And then if I die here, 10 F, etc. But I still hear the background noise, even in the game over screen. We wrote logic to not have that, so there's an issue. So how are we going to fix it? So the issue stems from probably here. So in my original code base, what I wrote was that if main.js, if you do this, so yeah, give me a second. So there's an issue here because I forgot to pass in game.js. Okay, I did pass it here, so that's strange. There's something strange here. Ah, I see. I don't need to pass this as an object because the gameover.js function, the gameover function, expects this as the first param and immediately to have access to it. So the error I did was to pass it as an object here. To just pass it as the second param of the go function immediately. So now if I look at the result and then you hear the city sounds, maybe you don't hear it, and then I die. Oops, I didn't die. Now everything is silence. So you hear the hurt sound of Sonic, and then everything is silence here in the game over screen. All right, so that's the game. Hope maybe I need to teach you, of course, how to put it on itch.io or some website. So what you need to do when you have done your project, so I'm just going to close a bunch of tabs just to free things up, is you need to open up your terminal, and you need also to create, first of all, you need to create a vite.config.js file. Then you need to import define config from vite, and then you do export default define config, and then within it you pass in an object. And in this object, first you need to specify the base as being dot slash. If you don't do that, you're gonna have issues. So what you're gonna do now is you close the game. You do npm run build. npm run build. It's going to build the game and create a dist folder here. And then if you want to check that the output actually works great, you do npm run preview. And then I'm just going to copy that link and then paste it here. And then your game should run without any issues. Now the only thing left, of course, is that you take the content of your dist folder. You zip it, and then you can host it on itch.io, GameJolt, etc. So this is actually what you distribute. All right, that's how you do it. So hope this tutorial was helpful for you. If you enjoyed it, feel free to subscribe for more content like this, and thanks for watching. Bye.